is used in the textile and leather industry. With that, I can do some pattern matching. I can do leather capture. It really allows for a lot of flexibility when it comes to the cutting process. So let's get started. I'm going to go to the computer and bring up a material and nest some parts, and then we'll cut some things. So first, I'm going to make my material. I have a few different options when it comes to making materials. For this demonstration, I'm going to just make it manually, what mine calls interactively. We use the pattern materials, make it out of a rectangle. We'll see a little later that we do have some flexibility when it comes to where we place this, so the initial size isn't super important. Once I have my material made, I can align it, hit OK. Then I have the ability in here to do manual nesting, where I place parts manually using the projector or just my computer screen. But for this purpose, I'm just going to do some automatic nesting. Hit the play button. It'll nest automatically, trying to fit as many parts as it can in the area that I gave it. We got 14 parts. I had 50 in my code order, so not terrible statistics. This is a dual beam system. We will be using one of those beams to simulate being as our G3 system would be. Once I have my nested piece, let's realign it with the projector to make sure we're on the actual material that's on the table. Perfect. Now I'm able to press this play button and do some cutting. So once I press play, the machine will feed the material forward onto the actual cutting area. We'll do a short feed to get everything in. Then we'll start cutting. Tool we're using is our power rotary tool. There is a spinning wheel that's spinning independently of the beam moving right now. So that allows us to create almost zero drag force when we're cutting. With a porous material, we're not going to get much vacuum hold down, even though we have the vacuum on. So we want to create as little friction in the material as possible. You see a lot of other companies, they'll have plastic over the top. We don't need that with the use of this tool. So we have the options of a lot of different types of tools with the Zune. Drag knives. So at that time, this little piece right here, we broke a light barrier. So to relieve that, we'll just knock that back down. Acknowledge that we broke it. The little safety feature that we have doesn't really stop our production. If I wanted to move it out all the way off the table, I can. Make sure it doesn't happen again. Put the machine back online and keep going. Like I was saying, we have a variety of tools available to us, whether it be drag knives, rotating knives, oscillating knives. We have a router that we can attach to the machine, a laser for seaming fabric that frays. It's really, really versatile. You can go from cutting a material like this to routing later in the day with a very simple tool change. Well, the machine's out of the way, I'll pull this so we don't break another light barrier. Broke that quick. So the speed we're moving around the table is at 40 inches a second. The nice thing about the PRT is that we can go as fast as the machine goes because we're creating no force. A lot of times with the drag knife, we'll also be able to move at 40 inches a second. Really allows us to go pretty fast. We're also not limited to only doing one ply. So I don't know if you can see the actual motion of the tool head. It's not picking up when it goes around the corner. We could eliminate these material popping up just by having it pick up, but we'd lose a little bit of speed. So I'm willing to sacrifice some light barrier brakes just to be able to go fast. All that can be changed within the settings of the material. Now once it's finished cutting, machine's going to feed forward until into our pickup area. Then we'll be able to flash parts. If we had different parts on this nest, I'd be able to really identify which is which. Since it's all the same part, it'll just flash one color. If you can see over here, we have our part projected down. So as a pickup operator, I know exactly what bin I want to throw these pieces in. I said earlier, same part, so we don't have to think all that much. It's a little bit overkill on this one, but if we had multiple parts on a roll, it would definitely help us out when it comes to picking up and placing for the correct order. With this software, we can have cut orders come in from your ERP, straight from a spreadsheet, and then it'll nest based on that offline. So all the operator has to do is bring in a fully nested file and just cut it, make sure they have the right material. There's our parts. You can still see we have our projection down. That we're ready to bring in another file if we wanted to, or another material. So let's talk about some other features of our cutter. So as you can see, we have extensions again. The size of this machine, this is our 2XL 3200. So the 2XL is the width, just under 10 feet wide, 3,200 millimeters long, plus the two full extensions makes it around 9,200 millimeters long. The cutting area is 10 feet, so we can put a big piece on here. The size of this machine is actually designed for doing full hides of leather, so we can put a full hide on the back, capture it, nest it, and then move it forward into our cutting area. So it's very inline workflow orientated. We're in a lot of different applications, so we're extremely versatile when it comes to the types of material we can cut and how we transition through it. So really able to tackle most parts of your business. But that is our simulation and demonstration. If you have any questions about the cutter or want any more information, please reach out to info@zune.com or visit us at zune.com. Happy to help and have a good day. Thank you.